All right, hello. We just finished talking about theorem 1.13, and we're going to look at example 7. I decided this should be a separate video because this concept is probably more important than that proof, and just in case you fell asleep during the proof or something, I want to make sure you start a video fresh with this important thing. So we have this vector u is the point 3, 1 right here, and v is the point 1, comma, -1. And we're going to draw a list of vectors. If you want to try this on your own, that's fine, but I'll do it here too. So first of all, u plus 0v. Well, that's just equal to u, right? So that's right here. That's that point. Okay. U plus v means we're going to add a copy of v. Doing the tip to tail thing, and the point you end up with is right here. So there's u plus v. If you do u plus 2v, 2v is the same thing as v, just twice as long. And so connecting tip to tail puts you right here. 2.5v is a little bit longer than that. Negative v is in the opposite direction. So you get to that point. U plus -2v, likewise, is here. All right, so that's a bunch of points. The point of this exercise was to see the following result. In general, the set of points that can be written like this, given some vector u and some other vector v, points of the form u plus tv. So t can be any real number. So t is the thing that can be anything, but you're given a vector u and v like the example we have. It gives you a line that includes the vector u as a point, and the line is parallel to the vector v drawn as an arrow. So this is a good example of why sometimes you want to draw vectors as points and sometimes you want to draw vectors as arrows, because it helps to think of u as the point and the multiples of v as arrows, because that's what you're adding. Okay, so yeah, together you would get all points like this. So is this set of points like that a subspace of R2? Maybe pause it. Write down your guess on your own paper. And I'll tell you in 3, 2, 1. No, it is not a subspace. For one, it doesn't contain the 0 vector. If you take u and scale it, like here's 2u, this point right here, that is not in the set W, so it fails scalar multiplication. If you take two vectors in the set here and add them, like here's one vector, if this is your q and your p is equal to u, then q plus p is over here, also not in the set. So yeah, this fails all three conditions. Okay, so yeah, knowing this fact, we're going to use this every once in a while. We are done with 1.5. Hopefully this ended up being quicker than 1.4, and hopefully you have a little more time to do some of the exercises before class, and I will see you later.